Hello, now we're going to look at section 11.2. We're going to start getting derivatives again. I'm going to be doing two different videos for this. The first one is going to be with respect to exponential functions. Now, back in chapter 10, I showed you a way to check yourself with the n derive. I'm not going to do the difference quotient to show you that this works. I just want you to see that yes, it does work, and you can always check yourself. Alright, so I want to find the derivative of this function e raised to the x. So if you remember, with my e raised to the x, I do my n derive, which I'm asking the calculator to do. I type in the original, comma x in parentheses. Now in 3 here, which looks exactly like the first one, I typed in e to the x again. Interesting. Alright. So if you go do second table, your second graph for table, you're going to find that actually even if you see y1, y2, or y2, y3, they're all the same. So if you'll note what I've got here, since these two are equal, or even if you have y1 and y2, they are equivalent. That means that if you've got f of x is equal e to the x, then the derivative is itself. Odd, but that's what it is. But the issue here is, what if there's a different coefficient other than 1? The exponent is not just an x. Well, I've got a rule, and we're going to be putting these in the calculator. I want you to do that so you'll get in a habit to check yourself. Check this out, close, because there's two things that repeat. I don't put arrows just because I feel like it. Notice the constant comes up front. The e to the whatever goes in the back. Do you see the split? That's all I've done. Now, I've got to have a filler. Alright? Now, if you'll notice the filler, I've seen that notation, that's f prime of x. Well, the only f of x I see running around in this near vicinity is this exponent. So, if I get the derivative of the exponent, that means fill it here. Okay? So, in this particular problem, let's look. I want to find the derivative. So, I see an e. I've got to apply this. So I'm going to put negative 7 times, leave space, times e to the x. Well, what's the derivative of x? Should be 1. So let's see what I've done here. I'm going to move it this way. Well, maybe if I use my mouse, it'll go faster. So f prime of x, that's what I've done. This is what I'm saying. Move the constant up front, leave a space, parentheses, brackets, I don't care. But you need a space that you can put something in. Whatever your e is, whatever it is, it repeats. Totally, automatically, every single time. Now the next part, this is something old that we had back in chapter 10. The derivative of negative 2x is negative 2. The derivative of a constant is 0. I need to clean this up now, and negative 7 times 1 should just give me negative 7 e to the x minus 2. So let me get my calculator up. Let me go y equals. So I'm going to put my derivative, the one I found, in y1. So negative 7 second ln, let me put my x in there, minus 2. Now I'm going to go to math. If you remember, it's under 8. N derive. Now with this one, I'm asking the calculator for the numerical derivative. Remember, I've got to put the original function minus 2x plus 5 comma x in parentheses. Now I'm going to go to table, second graph. So since these jive, it has to be the same. The y1's what we did, the y2's what the calculator did, and if they're in agreement, I am happy. So let me put that down. Let's look at this one. I see 1, 2, 3, 4 functions. I see the 12. It's going to go away here in a minute. But here's an e. All right. Separate -9 times some grouping symbol, e to the -2x squared. There's my sum grouping symbol. Now, for me to fill it in, remember, I go and look at the exponent. So the derivative of -2x squared is -4x. 3 times -4 is -12x squared plus 7. You always, more than likely, will have a cleanup. So this is going to be 36x e to the -2x squared minus 12x squared plus 7. Won't you try number 3? I need you to, pause me. I'll keep going, but I need you to try before I move it so you see if you can get it right, okay? So I see the e, automatic. I'm going to have -2.5 times space times e to the 3x to the 4th. In the middle, I should have 12x cubed. Then I've got to get the derivative of this, which would be a -24x squared. And the 13 is going to go away. See, there's my -2.5. Remember, I said 12x cubed. There's my e, and then the derivative of that. So I need to simplify this. So if you multiply that -2.5 times 12, you should end up with -30x cubed minus e to the 3x to the 4th minus 24x squared. Don't factor, not right now. I just need you to be able to get the derivative. Okay? Now notice I didn't use a grouping symbol. I did use dots, but that still does the same thing. I am creating an actual physical space there that I got to fill in, but the big key is I got to know where to go to get it. Okay? Let's see the next one. Oh, lovely. This one's not bad. I've got -45x to the 8th, but I see an e and another e. You take the term separately. So I'm going to have 12 times space e to the 5x. What's the derivative of 5x? You should say 5. So I'd have 5 right here in the middle. I don't want that one. So there's that one. How am I going to get this where you can't see? Well, there ain't no way. So there's my 12. There's my 5 in the middle. And there's my e to the 5x. Now let's see if I did my next one right. I put my -10 times space. Remember, this 15x to the 4th is not there. You do not do that until you're ready to fill in. So that means I want the constant here, the e at the rear, and those two things do not change. Not when you put them down like that. The only thing that you're going to be substituting in is the stuff in the middle. The derivative of the exponent that's with the e. And the derivative of 3x to the 5th is 15x to the 4th. And when you have a number times a number, go ahead and clean it up. So this should give me 60. This should give me a -150. Now normally the order they'll go is they'll do constant, then e. Or if there's a variable, they'll do the coefficient, the variable, and e. I always put e at the rear end. I always put it there. So that right there should be enough for the getting derivatives of exponentials. So I need you to play with those problems and see how they go. And guys, you got to get very deliberate with this. Make sure things go where they're supposed to go. Okay? Because the stuff that we put in the middle is technically old. We had that in the last chapter. We've done that. So this is just using this sort of in a modified way. Okay? Talk to you later. Bye-bye.